Oh, hello there. This is Mr. Ferrante. This is problem 7 from the homework, and I'm going to run through it for you. Okay? There we go. So first, we had changed the problem from t, a, b, whatever variables they're using. We changed those to x's. So let's go ahead and change this problem to y equals 2. Instead of t squared, we got 2x squared plus 5x minus 3. So each of the problems you see in the homework, change them from the variables you see into just y equals in terms of x. The instructions are written above. First, we're going to find the x-intercepts using the quadratic formula, find the y-intercept, line of symmetry and vertex, and then graph using those 4 pieces. So here we go. For quadratic formula, you have to have that puppy memorized. So go ahead and pause the video and write down as much as you can of the quadratic formula and test yourself. So pause the video and I'll see you in a sec. Welcome back. Here's the quadratic formula. You can check to see if you got it right. Negative b plus or minus the square root of b squared minus 4 times a times the c value. The square root goes above all that stuff, and it's all divided by 2a. There's plenty of videos on the quadratic formula on YouTube, so just YouTube quadratic formula if you need practice with that, and you'll get a boatload of videos, and it's worth your time practicing until you can get it down every single time. So there's our formula. We need to find that what's the a, b, and c values for our problem, and they're the coefficients in front of the variables. So a is 2, b is 5, and c is negative 3. That includes the negative sign. So I'm going to go ahead and plug those into the quadratic formula. So we have x equals negative, just use parentheses, and let's put the b in later, plus or minus square root of the b value squared, but for now just put empty parentheses, minus 4 times, it'll be the a value times the c value, and then all divided by 2 times the a value. But for now, we're just using parentheses. Once those are there, now let's plug in our a's, b's, and c's. The b value is 5, so we have negative 5 plus or minus the b value squared minus 4 times the a value was 2. So we've got the a value times the c value of negative 3 all over 2 times the a value. And this needs to be simplified step by step. I see a lot of you in homework get messy at this point. Please stick to the structure. Don't just do crazy scratch work off to the side. Stick to what you have and simplify it one line at a time. So in the front we've got negative 5. We can just write that as negative 5. Parentheses are not needed anymore. Plus or minus the square root. And inside the square root we can simplify. 5 squared is 25. Don't do any more than just that. Then what's negative 4 times 2? That's negative 8. Then negative 8 times negative 3 is a positive 24. It's positive because there are 2 negatives being multiplied, and 2 negatives multiplied to a positive. All divided by 2 times 2, which is 4. And there we go. In one step, we've simplified from the plug-in version to one step simpler. We're going to continue that down here. This stuff all equals negative 5 plus or minus square root. We can add these together. 25 plus 24 is 49. And it's all divided by 4. Next step, simplify the square root. The square root of 49 is 7. So we've got negative 5 plus or minus 7. That's all divided by 4. And now we can take care of this plus or minus. Plus or minus means there are 2 possibilities. One, it could be a plus symbol. One, it could be a minus symbol right here. So if this symbol is a positive, we'd have negative 5 plus 7, all divided by 4. Or if we use a negative symbol, it'd be negative 5 minus 7, then all divided by 4. And there's 2 possible answers, so we have to compute each of them. Negative 5 plus 7 is 2. And we divide that by 4, you get 1/2 when reduced. Negative 5 minus 7 is negative 12. And then over 4, that divides in 3 times, and there's a negative, so we have negative 3. So these 2 values here are the x-intercepts, but we're going to write them as x-intercepts. So here for x-intercepts, let me get my eraser out and erase this guy. one sec. All right. Oh, man. Dude, I just erased the whole thing. Ain't cool. There you go. All right. Eraser. There you go. All right, for the x-intercepts, let's write these two values as points. 1/2 really means the x-intercept 1/2 comma 0. That's the official x-intercept. And the second x-intercept was at -3, but written as a point, it's -3 comma 0. So those are the two x-intercepts. Next up is y-intercept. Let me go back to my eraser and erase all this stuff here. So for y-intercept, really you can just look at the equation honestly and tell what it is without doing any work. I'm going to go ahead and show you the work that you could do, but sooner than later, I hope you get to the point where you can just look at the equation and see the y-intercept in an instant. To find a y-intercept the official way, you plug in 0 for x. So in this case, if you put in 0 for x, 0 squared is 0, and 2 times 0 will be 0. 5 times 0 would be 0, and you got -3. So really, every time to find the y-intercept, it's going to be this last term, whatever that term is. In this case, it's -3. So -3 is the y-intercept, but written as a point location, it's 0 comma -3. Next up, part 3, find the line of symmetry, and then the vertex from that. Fine. Let me erase this stuff here. You need to know the equation for the line of symmetry. The line of symmetry is x equals -b over 2a, and we already have our a and b values. So we have negative parentheses over 2 times parentheses. And we had said from before, when we did the quadratic formula, our a value is 2. So down here we'll have 2 times an a value of 2. Our b value was 5, so we'll put a value of 5 here, and compute. So we've got -5 in the numerator, 2 times 2 is 4 down below, and -5/4 is our line of symmetry. If you simplify this to a mixed number, 4 goes into 5 one time with 1 left over out of 4. So -5/4 is the same as -1 1/4. So line of symmetry is x equals -1 1/4. That's the official line of symmetry. The vertex is going to be the same x location, but it's a point, not a line. X equals a number is a vertical line. The vertex is a point at that spot for x, but the y-coordinate needs to be figured out. So to find out the y-coordinate, we're going to go ahead and use our equation and plug in the x-coordinate. But when you substitute, don't use the mixed number version. Use the improper fraction version. So we're going to plug in -5/4 in for x. Remember, we change these t's or b's, whatever they are, change them to x's. So we've got y equals 2 times the x value squared, then plus 5 times the x value, and I'll fill those x values in a sec here, and then -3. In our case, the line of symmetry is our x value of the vertex. So I'm going to put -5/4 in here for both values since they're both x's. And then let's compute. I realize there's fractions here, but fractions are more your friend than not. To square a fraction, square the top and square the bottom separately. -5 squared is +25, because it's a negative times a negative. 4 squared is 16, and there you go. On this side, make the 5 5/1. Then it helps remind you that fractions are multiplied straight across. 5 times -5 is -25, and 1 times 4 is 4. With the 3, we can just leave it as 3 for now. Now before you go and simplify this 2 times 25 and 1 times 16, there's an easier way, which is just to cancel. 2 goes into 16 8 times, and now you've got left over just 25 over 8. I think there's an easier way than multiplying first and then dividing. If you can divide first, just easier. And this will be a minus overall, since there's one of each sign. But before I write 25 over 4, I know that to add fractions, you need the same denominator. So I'm going to convert this to 8s by multiplying by 2 over 2. Because this 4, to become an 8, needs to get multiplied by 2. So -25 times 2 is -50. Then divided by 4 times 2 is 8. and that converted this fourths into eighths. The same thing happens with the 3. To convert this into eighths, you have to multiply it by 8 over 8, because there really wasn't anything down there except for 1. So negative 3 times 8 is 24. And then on the denominator, 1 times 8 is 8. Now I've got all 3 terms in terms of eighths, so you can just go ahead and add them up straight. 25 minus 50, a little scratch trick here, will be negative 25. And then minus 24 more, minus 24, will add up to a total of negative 49. So this is adding up to negative 49 eighths. And as a mixed number, 8 goes into 49 6 times, because 6 times 8 is 48. So there's 1 left over. So negative 6 1/8 is the y value. So the vertex is located along the line of symmetry at negative 1 1/4, and its y value is negative 6 1/8. Last step is to plot this information, which I know seems a little daunting to those of you thinking the fractions are going to be messy to plot. They're not so bad. I'll show you in a sec here. I'm going to do this by hand without a graph, unfortunately. For you, please turn your worksheet over and use the graph provided. I'm going to go ahead and make just kind of a sketch. Yours should be much neater than mine, especially since you have graph paper. So there's my y-axis, my x-axis. Let's plot the x-intercepts first at a half comma 0. Let's say this is 1. Then there's a half comma 0. Negative 3 comma 0, negative 1, negative 2, negative 3 comma 0. The y-intercept is at 0, negative 3, 0, negative 1, 2, negative 3. Then the line of symmetry is at x equals negative 1 1/4. So if you go over negative 1 and a fourth more, you can draw a vertical line here for the line of symmetry. Same thing, it's splitting the parabola into 2 equal pieces. And the vertex lies right along that line at negative 1 1/4, down 6 1/8. So down 1, 2, 3, 4, 5, 6, and a little bit more, just barely past the negative 6 mark. And now we've got one more point to plot. This point right here, the y-intercept, will be reflected across the parabola to create a partner over here. Because remember, parabolas are symmetric, so any point you see on one side of the parabola has to have a mirror image on the other side. So I just kind of added this mirror image here. So we've got our vertex down here at negative 1 1/4, negative 6 1/8. We have our x-intercepts, our y-intercept, and its reflection. And now we can graph a nice parabola, which yours will turn out better than this one, but the idea is clear. There's our beautiful parabola, all dressed in black for the evening, and we're done. So you can rewind this as much as you need to. Next video will be problem number 8, and the rest will be on your own. All right, have a great night. Bye.